All right, welcome guys. We're taking a look today at the 9-6 review of solving quadratics. Remember, we're going to have a little live stream at noon tomorrow. So if you want to take a look at that, feel free to join. But here we go. So for 9-6, we're taking a look at factoring completely to start with. Remember, we're looking for a checklist, GCF, perfect squares, trinomial, and then we're always looking to see if we can keep factoring each of those factors. So the first one has two terms with a minus. This is a difference of perfect squares. So this is going to be x squared plus 4, and then x squared minus 4 when we do the square roots of x squared, x to the fourth, and then 16. The first term we cannot factor. So this x squared plus 4 stays as is because there's a plus sign. But the second term is a difference of perfect squares. So this is going to factor into x plus 2 and x minus 2. And this is going to be our final answer. All right. Likewise, the letter B, we also can factor this one. Now this is three terms, so normally we would think trinomial, but remember we always want to try a GCF first. There is a GCF. Take it out right away. It'll make your life easier, okay? So x squared plus 6x plus 8. There should be an x there. And then once again, we still can factor the inside, so we have to keep going. So the factors of 8 that add to 6 are going to be 4 and 2. So this is going to be x plus 4 and then x plus 2. And then that 2 has to stay in front so that we're factored completely. Okay, letter C is going to be, there is a 2 in front and we can't get rid of it. So this is when we're going to do our factor by grouping. So we want to multiply to negative 10 and we want to add to 3. So this is going to be 5 and negative 2. We are going to rewrite the 3c as 5 and negative 2 instead. So it's going to be 2c squared plus 5c minus 2c and then minus 5. Now you could switch it around and put the minus 2 first, right? Minus 2c plus 5c plus minus 5. It doesn't really matter. Which way you put it in, you'll get the same answer. Just what's in the parentheses and what's in front is going to switch. So since we started with our original amount, plus 5c minus 2c minus 5, we're going to keep it here. So the GCF of the first term is just c, and there's 2c plus 5 left over. Remember, the minus sign stays. There's nothing in common between 2c and 5, so we're taking a negative 1 out. And then we have a 2c plus 5 left over. So you can see what's in the parentheses is the same. And then our answers are the inside guys, which is the 2c plus 5. Okay. And our outside guys, which is the c minus 1. And that is factored completely. Okay, same thing for number 10. Don't have a GCF here. So this is going to be a factor by grouping question. All right. So we want multiples to do a times c on the top. So that's how we got the negative 10. And then b on the bottom, which is where the 3 came from. So 10 times 3 is 30, right? And I want to multiply to 30 and add to 17. And in this case, it's going to be 15 and 2. So we're going to rewrite our middle term here with 15 and 2. So it's going to be 10t squared plus 15t plus 2t plus 3. All right, and you can see in the first two terms, we have a 5t that's in common, which leaves us with 2t plus 3. And we don't have anything in the second one that's in common, so we take the 1 out, and we still get 2t plus 3. So our inside guys is 2t plus 3. That's one factor. And the outside guys is 5t. Whoa, wrote x there for a second. 5t plus 1. And there's our two factors. So, solving the following quadratics. Remember, get standard form. So get everything on one side. Make sure the x squared stays positive. And then you're going to look to factor from here. So we're going to take a look at the first one. We're going to want to distribute this x before we do anything here. So x squared plus 5x equals 5x plus 16. Okay, the x squared is positive on the left, so we want to move everything over there. So we subtract the 5x from both sides. All right, So x squared equals 16. We'll move the 16 over as well. And we get x squared minus 16 is equal to 0. And then I can do my factors. So this is x plus 4. X minus 4 is equal to 0. And I'll show you another way to solve this in a second. And then our zero product property, if x plus 4 is equal to 0, the other one is x minus 4 is equal to 0. There has to be an or in between because it could be either of these. And then our two answers is x is equal to negative 4 or x is equal to 4. And we're going to write that in our solution set here. So negative 4, comma 4. Now the second way to do this is at this step, when we get x squared equal to 16, we could also just take the square root of both sides. But remember, whenever you physically put in a square root, you need to take the plus minus here, okay? We'll talk about this a little bit later, but this is a second way to do this, and you'll end up with the same solution. You'll end up with either x is equal to positive or negative 4. So if you haven't seen this, we'll be working on this in our next unit after our spring break. So just keep that in mind as we get through here. All right, for letter B, same thing. So we want to do our x plus 5 squared. Remember, x plus 5 quantity squared means multiplied times itself. So we want to go ahead and distribute together to get x squared plus 5x plus 5x plus 25. So this is x squared plus 10x plus 25. And then we're going to bring that back into our question. So x squared plus x squared plus 10x plus 25 is equal to 37. And then we'll take the 37 away from both sides. We're also going to combine the x squareds together to get 2x squared plus 10x. And this is going to be minus 12 is equal to 0. So remember we talked about, first thing we look for is the GCF. There is a 2. We're going to take the 2 out. And then we get x squared plus 5x minus 6. And then can we factor what's inside the parentheses here? And the answer is yes. Okay, so the 2 stays, right? I want multiply to negative 6 and add to 5. So that's going to have to be 6 and negative 1. And we're going to get x minus 6 times x. We just did that wrong. X plus 6 times x minus 1 is equal to 0. Now they're technically 3 factors. We set each equal to 0. Remember, 2 can't be equal to 0, so that answer is done, okay? But x plus 6 could equal 0, or x minus 1 could equal 0. And so if I solve, I'll end up with x equals negative 6 by subtracting 6 from both sides, okay? Or I'll end up with x equals 1 by adding 1 to both sides. And so my two solutions here are negative 6 and positive 1. All right, on to the next page. Solve the following systems of equations algebraically, right? So remember, system of equations, we have to set them equal to each other. So solve for y if that's not done already. Set them equal to each other and then solve. So here we're going to do x squared minus 7x plus 5 equals x minus 10. And then we're going to go ahead and solve. So x squared is positive on the left. So we're going to move the x and the 10 over to this side. So I get x squared minus 8x plus 15 is equal to 0. There's no GCF. 3 terms, so it's a trinomial. We want to multiply to 15 and add or subtract to give me negative 8. So I need both negatives. And hopefully you guys are recognizing negative 3 and negative 5. All right, so this is going to become x minus 3 times x minus 5 is equal to 0. And then we'll do a 0 product property, so x minus 3 equals 0. Or we're going to do x minus 5 is equal to 0. And then we end up with x is equal to either 3 or x is equal to 5. And I'm sorry, I'm writing sideways here. And there's our answer. Now, remember, timeout, that is not how we do our answer. The answer to a system is not the solution of the 2 roots. It's the points. So we have to go back to our equation and plug in 3, so y is equal to -7, and 5, and y is equal to -5, and our solution is actually the points. So when we plugged in 3, right, we ended up with -7, so the point is 3, -7, and the second solution is we plugged in 5, we got -5, so it's 5, -5. There's our answer for the system. All right, so be careful when it's the roots versus the system. All right, 4, solving it graphically. Remember, first thing you want to do is graph it on the calculator if you can. Now, we can't graph this function as it's written. If we do a relation on the calculator, remember how we talked about deleting, let's pause for a second here while I get the calculator out. All right, we're back here. So remember, if we go to the graph, we talked about we could delete this and choose a relation, and then we could just graph any equation. But the problem was when we do that, we don't get a table, okay? So if I do y equals like 2x, I can't do a table. It doesn't let me do it. So that's the downfall here, okay? So we got to keep that in mind as we go along, that we're going to solve for y first. So we want to add x to both sides. Put the x in front, remember mx plus b, and then divide by 2, and we get y is equal to really 1/2 x, but x over 2, and then plus 2. All right, and our other equation is our quadratic. So we're going to go ahead and type in both so we get an idea of where these are going to cross, and if we can choose a scale of 1, do we have to increase the scale to 2 or 3 or something else? So let's type these in. So we're going to go back to our graph here. Okay, hopefully you're doing this on yours. And we're doing -x² plus x minus 5. So -x² plus x minus 5, just double checking. All right. Oh, look at that, way down there. Okay. And then we're going to go to the next line. So remember, we pressed tab. Actually, let's get out of there. Tab. And then we got 1/2 x plus 2. So we're going to do control divide to do 1/2 x plus 2. And okay. So lines aren't crossing, right? Which tells us, and remember, we can change these numbers here to -10 and 10, so we get a better idea of our graph. If you want to get to kind of match up to the one we have. Shout out to Lucas for that. These aren't crossing, guys. So should there be a solution? Remember, solution is the intersection, and there isn't. We'll talk about how to write that on a graph. So the first thing we're going to do is identify what the vertex is for our point here. So we can graph on the graph we have. We don't have to change the scale. So we're going to go to Menu, Analyze Graph, and we're going to choose Maximum. And then we're going to go ahead and it says which graph. So we either have to select Graph 2 or Graph 1. So go ahead and click on this graph. And then we're going to go ahead and open that up. And there is our vertex. So we know that point's going to go right in the middle. Okay. So I'm going to make an xy table, y equals -x² plus x minus 5. So xy table. All right. We know we're going to put 0.5 in the middle. We're going to choose whole numbers around it. So there's 0, -1, -2. We might not be able to graph all those, but we're going to put them down. And then 1, 2, 3. So I'm going 7 points here. 0.5 was -4.75, -4.75, and then I'm going to go ahead and open the table. So remember, the parabola is the first graph. So 0 is -5, 1 is -5. All right, 2 is at -7, and so is -1. And we'll see if we can fit the other one on there. -11, we can't. So this one is going to be off. We're going to put it down, but we're not going to graph it. Okay. And then the two things we need for this line are the m, the slope. Remember, rise over run. So that's 1/2. And b, the y-intercept is 2. All right. I am going to go ahead and put the line in blue. So don't mind me for a second here. Can I do that? No, it's not going to let me. Awesome. We're going to go ahead and just put it in blue here. So All right, so we're going to graph the line first. We're going to go 2 on the y-axis, and then rise over run means we go up 1 over 2, and we're going to get this line right here, or down 1 over 2, and we're going to get this line. So I'm going to go ahead and select my line, and then graph this out. Remember, you just need a straight edge. You'll have a ruler on the exam. For our purposes, or even an index card, you can have just anything that will let you graph a straight line is really all we need here. So, all right, so here's our first graph. All right, the second graph, we're going to go ahead and put our points down. So we can't graph -2, 11. We can graph -1, 1, 2, 3, 4, 5, 6, 7. Oh, just fitting on the screen. 0 is at -5. -0.5 is -4.75, so just over. And then we're heading back down. So 1 is -5 and 2 is -7. I am going to move down here a little bit. All right, and we're going to draw our curve in for ourselves. Now, points are a little bit off, you can kind of see here, but we'll make that work. And we know we don't want to cross -2, okay? We don't want a line to go this way because we can't cross before 11. So just make sure that when we head down this way, we start heading towards where that point's going to be. And we're going to do the same thing over here. All right. Now, full credit graph, the answer is technically no. I don't need labels because there's 2 different equations, but one's linear and one's quadratic, so they're not the same type of equation, but I need an arrowhead on this line because I didn't extend it all the way. So just remember, put arrowheads on your lines, guys. Get used to labeling them. All right, because if there are 2 of the same line and you're in the habit of not labeling, you are going to lose an easy point here. And we need all the points we can get. Make sure we secure that high grade here in our exam. X squared plus x minus 5. Also remember, it's perfect practice that makes perfect. So this is what we're working with. Now, we also have to state the answer. So all we have to do somewhere is make sure we put down that there is no solution. Okay? If you want to get specific, or if it asks why, we could just put down that the graphs don't cross. Or don't intersect. But for our purposes, just no solution is all we need. All right? And we got one more, our Sierra test the ball question up in the air. When is the ball at its highest point? What's the maximum height? Remember, the highest point occurs at the vertex. Okay? The time is the x value. That is our axis of symmetry. And then the actual height is the y value of the vertex. Okay? So we're going to do our x equals -b over 2a here. We know that a is going to equal -1. It's in front of the x squared, and b is equal to 6. So x is equal to -b, so that's -6 over 2 times -1. So x is equal to -6 over -2, which is 3. So we can say after 3, and just check your units, make sure we're right, seconds. All right, ball is at its highest point. Okay, and then we're going to plug into our equation. So y equals negative, parentheses, 3, okay, squared, plus 6 times 3. Now, what we're going to talk about, this is a great example of why we're using parentheses here, okay? So if we use parentheses, let's see the answer we get. All right, so we're going to go back to the home screen. We'll choose a new document. No, I don't want to save. Calculator here. So we're going to do negative parentheses this time, okay? Parentheses. And we got 3 squared, okay, plus 6 times 3. All right, we end up with 9. Now, here's the important part. All right, had I Actually, the parentheses don't actually matter in this instance, but they do in certain cases. If I was plugging in a -3, if I was doing -3 squared, okay, we're going to get +9 versus our -3 quantity, or not quantity, but squared, okay, is going to end up being -9. So because the negative is outside the parentheses instead of inside, we end up with a negative result instead of a positive result here. All right, so negative parentheses 3 squared, okay, is going to end up getting you -9 rather than inside the parentheses, which is +9. So just be careful here. So we know that this is going to be -9 plus 18, -9 plus 18, which is equal to 9, and that is what y is equal to. Okay, so we're going to say the maximum height. Be careful of the units here. Okay, this is in meters. All right. So we can say the ball reaches a max height of 9 meters. All right. And the last thing we want to do is how far will the ball land from Sierra? Remember, those are the roots. So we want to take our equation and set it equal to 0. So 0 equals, and here we're going to have our equation, which is -x squared plus 6x, -x squared plus 6x. Okay, we can't deal with that negative in front, so we're going to divide everything by a -1 to flip the sign. So 0 is equal to x squared, and this is -6x. And now we can factor. So first thing we look for, once again, GCF. So x comes out first, and then x minus 6 left over. And then we're going to go ahead and set each of these equal to 0. I get my first solution, which is at 0, and the second solution, which is at 6. Okay. So it says, how far in meters will the ball land from Sierra? Now, this is a tricky question because this tells us, right, that the ball is going to land. It's going to take 6 seconds to hit the ground. But that's not what this is asking. This is asking how far in meters will the ball land from Sierra. So it's modeled by this equation. This represents the height of the ball. Pausing for a second. Yeah, so we can't actually answer this part of the question. We don't know how far in meters the ball will land because our equation just tells us the height and the time that it takes to get there. It doesn't give us the distance. It doesn't tell us how fast you threw the ball, so we don't really know like the speed of the ball. If we knew that, let's say you threw it and it was going 20 meters a second. If it took 6 seconds, we could get the speed and the distance covered. So instead, this question should be how long, okay, how long in seconds, right, will it take for the ball to land after Sierra throws it, would be the question this should be asking. And this would tell us that it took 6 seconds for it to hit the ground. So not the question of how far, we don't know that. We know the height at the ground is 0, so that's why we can't say what's going on here. But that's it for this one, guys. I'll have a worksheet for you guys for tomorrow sent out so you can take a look at, and we'll be working on some more review for solving quadratics. All right, guys, have a good day.